Ascend Beyond Airflow webinar. We're talking about revolutionizing your data pipeline orchestration today. So with that, and without any further ado, let's get into it. So I'll introduce our two helpers here today. We have the smart guy and the marketing guy. It's the way that I like to think about this. We're joined by Alesh Mistry, and Alesh is a solutions engineer here at Ascend.io. Alesh has had lots and lots of experience working on data infrastructure, data pipelines over the years, working at a lot of very impressive companies and working more primarily with a lot of really impressive clients to help build out a variety of different types of data infrastructure. So super excited to hear from Alesh. And as I said, he's the smart guy on the call. So if you have any questions, definitely address them to him. And Alesh, good morning. Welcome. Thank you for joining.
Yeah. Hi, everybody. Good to be here.
Great to have you. And the other thing to know about Alesh, fun fact, he's based in London in the UK. So for Alesh, it is in the afternoon. And we're really happy to have you with us. And then my name is Paul Lacey. I'm the head of product marketing here at Ascend.io. And I have had also a long career marketing technology products, especially in the data space. I've worked with technologies dating all the way back to Hadoop. And now we do everything in a more scalable way in the cloud. But have a lot of domain expertise and experience with building out products and working with customers and things like that on the marketing side as well. But yeah, so those are the two folks that you'll be hearing from on the call today. And then in terms of our agenda, we're going to go through a very brief overview and an intro to orchestration so we can set the stage and agree on some terminology when we talk about orchestration. Then we're going to talk about the two solution overviews we're going to look at today, or the two ways of doing it. We're going to look at Ascend and we're going to look at Airflow. And then we're going to get into the real meat and potatoes of the webinar, which is we're going to build some stuff out and we're going to get into terminals and we're going to start writing code. And this is going to be the real fun part of the webinar. We're going to go really fast so we can get to that as quickly as possible and spend as much time as possible actually looking at how you do it. And then we'll come back for a few learnings and takeaways as we wrap up the session. And of course, there is Q&A at the end of the session. Perfect. So let's get into it. So what is data orchestration? Now, a lot of people, when they think about orchestration, they think about a conductor conducting an orchestra. Because when you're building out data workflows and you're building out data products that are the results of data workflows, there's a lot of different things that need to happen in sequence. And oftentimes very tight sequences, like you need to ingest data and then you need to do some work on it, transform it so that it's compatible with other schemas in your overall data landscape. And then you can integrate it more tightly and create these data products that come out the other side that folks in the organization can use to do really smart stuff like build AI engines or build really sophisticated models that can help drive the business. So orchestration is that meta layer that goes on top of everything and says what needs to happen when, in what order, and what do we do about things when they don't happen properly. So a lot of times in the old world of ETL, we used to talk about the control flow and the data flow, whereas the data flow was the actual logic that owns the transformations of the data, and the control flow was, okay, and how do we execute all these different moving parts in a specific sequence? So that's a kind of broad view of what we mean when we talk about data orchestration. And to some extent, there is some infrastructure underneath, but we're not talking about orchestrating large portions of your IT infrastructure here. We're just talking about primarily the data pipelines that are running on that infrastructure and how we can do that more efficiently. So that's one view of orchestration. Although if you spend any time working around data orchestration, you might feel like this is a more apt explanation of what's going on. But you have a lot of repetitive tasks that come at you when you're working with data pipelines. And there's two responses people oftentimes have. The first is this person over here on the left who's really trying to just stay on top of all of it and really struggling to cope and stay ahead. And then you have the opposite extreme, which is just, I'm just going to do my job and if it doesn't work out, then so be it. And neither one of those are really a winning strategy for dealing with data pipelines, where things break and there's a lot of repetitive tasks that need to happen with error handling and things like that. And so part of what we want to do with orchestration is say, how can we get in front of these things and how can we start to automate some of these things, these repetitive tasks, so that people can do more intelligent work on the assembly line, so to speak, of the data and not so much reactive work where they fall behind. So that's going to be a big theme of today's webinar, as well as what are some of the techniques that you can use to try to achieve some of that automation So you don't wind up in either of these two camps here, being frantically behind the game all the time and stressing out about it, or basically just checking out and saying it's a losing proposition. So that's data orchestration. Let's get into the two kinds of solutions that we're going to be looking at today. So the first one is Airflow. A lot of folks on the call will probably know this is Apache Airflow and the open source solution. And it's very popular, very common in data infrastructures today and modern data stacks. It's invented in Facebook, for those of you that, or actually it was invented at Airbnb, excuse me, by a former director of Facebook, of data science at Facebook, and became the de facto solution for an open source workflow automation platform. It's extremely extensive in terms of what you can do with Airflow. Airflow can do all kinds of stuff, and all the way down to orchestrating cloud infrastructure. It's very tangentially related to data. So there's lots and lots of open source plugins that you can use, a huge community around it. It does require a lot of setup and a lot of continuous configuration tuning as you scale it out. And so that's where there's a lot of expertise that's required to really build out infrastructure with Airflow. We're going to be taking a look at some of that when we get into the terminal and we start looking at the code. But just to give you a preview, there's a lot of different components in the Airflow solution, as you might imagine, for something that's trying to take on such a large portion of day-to-day management. There's a lot of different things that have evolved, a lot of concepts that you need to stay in front of. And then there's just a lot of domain expertise required to get performance out of Airflow at scale. That can be a challenge for folks, especially for leaner teams where they need folks to be more focused on the data logic themselves, as opposed to working on the infrastructure, working in the business versus working on the business. There are some challenges that we'll go through and ways to mitigate those. And it's a very code heavy approach. And Airflow does have a UI where you can see some status updates and information. But for the most part, if you're working on Airflow, you're going to be in the terminal, you're going to be in file folders and structures, and you're going to be tunneling into remote servers and things like that. So it's a very code centric approach. The primary way to build and interact with Airflow is from the command line. So that's solution number one. Solution number two is that we're going to take a look at today is Ascend.io. And Ascend is the world's first platform for creating automated data pipelines. And what do we mean by that? We're talking about how can we bring a higher level of automation to your data pipelines, and especially to your orchestration of those data pipelines, so that you don't have to spend as much time mired in the weeds of what needs to happen. And we'll get into a little bit more of that. But the platform itself looks like three core planes. If you think about it like a data architect or an infrastructure architect, there's the build experience, which is where you do all your work of defining your data pipelines and setting up the ingest and setting up the transformation logic in SQL or Python scripts and sequencing those together in DAGs, et cetera, et cetera. And so all of that stuff we're going to take a look at today is very familiar to anybody that's ever built a data pipeline before. And you'll recognize that some of the efficiencies of being able to do it in a low code infrastructure way. Of course, there's also the reverse ETL component as well, where you share it back to various places that it needs to live. And it runs on a lot of the major data clouds, including BigQuery and Snowflake and Databricks. Above that is the control plane, which is where most of the automation happens. And this is more the behind the scenes where the platform is actually looking at the transformation code, is looking at the data, it's matching the two together to understand where has work already been done, where does work need to be done in terms of the definitions of pipelines. This is where we say we put most of the automation into the orchestration of your data pipelines. And this is by and large, you get this for free. If you build the entire workflow on Ascend, you get all the automation from the control plane. Just kind of happens, and you can just set some configuration parameters around it and enjoy the benefits. And then finally, there's the governance plane, which is where obviously you're keeping an eye on stuff and figuring out, hey, is this working? Is this not working? Did this run? How much is it costing me in terms of the amount of Ascend credits that you're spending, but also the amount of data credits you might be spending or consumption credits in your underlying data platform. And of course, also observing things and understanding lineage of different pieces of data and things like that as well. So all that kind of stuff is built in to what we call the automation platform. But to get into a little bit more detail, and then we'll get into the weeds, but I think it's helpful for us to have this as a background, is when we think about requirements for automation, Now, a lot of this is very much like an assembly line. We have things that are going down the line, and various things are happening to the data, the packets of data at specific steps, et cetera, et cetera. And in order to make a complete data product at the end. And the very first one is integrated tooling. You can imagine if each one of these robots on this assembly line had a different interface, that would be really difficult to automate, right? It would be difficult to set up each one individually. It'd be even more difficult to get them to talk to each other. There'd be a huge integration challenge, and you'd spend most of your time actually working on that and very little time specifying the overall assembly line structure and what needs to happen throughout the flow. And so that's the very first thing that Ascend has been focusing on when we started to build out the platform. Is if we look at the current modern data stack, a lot of people are using a wide variety of tools, and many of you on the call today might actually have this as your reality, where you've got lots of one or potentially many different ways that you ingest data. You've got many different ways you transform data. You've got many different solutions to orchestrate all of those individual tools that are doing individual steps of your data pipeline process. You've got extra tools you need to buy to reverse ETL or share that data out, and then even more tools to add to the stack in terms of observing everything and making sure everything is working properly. And by the time you just get through all this stuff, that's the huge amount of work that's required to basically build the data pipeline. It's just integrating all these different tooling, creating the stacks, maintaining each one, upgrading them on a certain cadence, all these different sort of things that need to happen can get to be a large volume of the work when you're trying to do other things. And so one of the innovations that Ascend has been pursuing is to create a single experience for ingesting, transforming, orchestrating, and sharing data on a single platform. So there's no need to piecemeal stuff together. We built it in a very open and extensible way, which means that if you do have other tools that are doing other parts of the process, we integrate very well and we work alongside those tools quite well using our open metadata bus and some other techniques that we've developed. But our primary objective is to say, let's just make this as simple as possible. If you're building a data pipeline, just build it in one place, have all the tooling and components that you need to be able to do all the core activities around a data pipeline in one place. And then we'll be able to have the integrated tooling that we can use to start to build some automation around that too. So we don't have to build a lot of bespoke integrations before we can consider that. So that's the first requirement. The second requirement is partitioning and metadata. And so as we think about first of all, we have to start thinking about data and data sets as partitions, not as giant blobs, if we're going to achieve a level of scale and automation. And the reason for that is we need to understand how we can segment the data sets and say which data sets have been processed at which times by which versions of the code base. And if there's a change in the code base that defines the logic, what does that do to the data sets? Which data sets are out of date? Which data sets are still compliant? And then where do we need to go and apply additional processing in order to bring the overall data set up to compliance? So we achieved that with smart partitioning. So we can say, okay, let's break up a giant table into multiple partitions and track each one individually. And then we have tremendous amount of metadata around the data sets to say, when was it processed, by what version of the code, et cetera, et cetera. And if I make a change, where does that change manifest and propagate throughout the data pipelines? Then you're able to start to see some of the amazing automation potential once you have this kind of information. And there are a lot of folks that are probably out there, and maybe even some on the call today, who've attempted to or even successfully built systems like this in the past. And if that's the case, then hats off to you, because it's an amazing innovation and amazing when you get to work at a company where you have the bandwidth to go out and build systems like this. But what we've built is the platform that creates this at scale so that you don't have to worry as much about this. You can just take advantage of the benefits and you can set up your partitioning strategies, and then we will take care of the metadata collection and management. And what this does is it allows you to be able to handle change much more easily, as you might imagine. So you can imagine if you have a change to a particular pipeline, most folks that are working in traditional kind of data stacks will have to figure out exactly where that change happens, but also what's going to be impacted by that change all the way down through the data pipelines that are dependent or that are reliant on that particular pipeline that you're doing the work in. So that's a tremendous amount of work, and it can be really difficult for folks What we oftentimes call this impact analysis, and it's a dirty word, but it is a big part of the role and big part of the job. If you're making a change and you need to know, is this going to break SLAs downstream, or is this going to invalidate data sets that now need to be reprocessed and all this kind of stuff? So that's a lot of work. But as you can imagine, if we have the metadata about each individual partition and each individual step of the pipeline, we can say, okay, if a change happens to step number 3 in a pipeline, and then there's other steps in other pipelines downstream also dependent on that same data set, we can say we know exactly which parts of the data set across all pipelines are going to be affected, and we can just go and apply change to those individual steps. So we don't have to do it on a manual kind of retry or spray and pray basis, or just go and rerun the entire pipeline sequence because we have to. We know exactly what to do with that change. So that's a huge advantage and a huge benefit of having this level of data and metadata about your data sets, so we can drive this kind of automation. And the final one is, this all leads up to being able to have an intelligent data pipeline controller, where in a SENS world, we think about setting up the outcome that we want to have happen and having the data pipeline controller go and figure out what needs to happen on the underlying infrastructure to make that a reality. And many of you might recognize the Nest thermostat here and appreciate the fact that we just, with a thermostat like this, we just set the temperature that we want, and we don't have to set the refresh rate of the burner. So how often does the heater need to kick on, what the hysteresis, all this kind of stuff is handled for us. We just say, I want the room to be a certain temperature, and the controller goes off and orchestrates everything to make sure that happens. And in a SENS world, we do something very similar in that we say, here's the data pipeline logic that needs to be applied to every piece of data that comes through this part of the pipeline, both now and historical potentially, and we can change that. But basically, and then we say, controller, go make sure that this happens and make sure everything downstream is also compliant and updated as well. And the controller will go off and do all that stuff on our behalf. And so that's really where we start to see the power of the automation come into play, and setting the scene for some of the things that we're going to see when we get into the command line here, and understanding the differences between those two approaches. Without any further ado, let's get into the code, and I'm going to go ahead and hand this over to Mr. Mystery. And Alesh, please go ahead and take it away. I will stop sharing so you can share your terminals.
Yeah, sure. Okay. Hopefully, you'll be able to see my screen now. Okay, so essentially what I've got here, sorry, it's a little bit confusing. You'll get used to it in a second. What we're going to do is actually kick off some of the artifacts that are needed to actually set up Airflow in the first place. So remember, I'm doing this on my Mac, but first of all, what we need to do is have a web server set up. So I'm going to kick off my web server, and then another artifact that Airflow needs is a scheduler. So those are the two main components that need to be set up in order to run Airflow. Now, if you think about doing this in anger, if you'd have servers, you'd have some infrastructure, you'd have to worry about maintenance, you'd have to worry about upgrades. So all these, what I'm doing here is a very basic example. But essentially, what you're doing is you have to consider the servers which are essentially orchestrating the work for you. And that's just a quick example of a couple of the servers that need to be kicked off. Then, of course, you need some code. I'm just going to kick off my IntelliJ IDE. Sorry, it looks a bit weird, but it's just so that everything fits on the screen. But you can actually see I've got a little IDE. Doesn't normally look like this, looks a lot more sensible, but just to show you, and hopefully you can actually see a little bit of code there on the right-hand side. But essentially what we've done here is that I've got a Python code, which is essentially a DAG, which I've created. Now it's one of the template DAGs, but essentially what it's doing, it's got a DAG, has got a number of tasks which you can actually run, and then subsequently they form essentially a DAG. So let's head over to my web browser here and just show you what I mean there, because I didn't explain that very well. So what we did here is this tutorial 1 Python code translates to a DAG. And you can see here you've got each one of these is a task within the DAG. Okay. Now, what I'm going to do now is that I'm actually going to run one of the tasks in the DAG. Okay, so let's head over. Let's just move that away for a second there. Okay, so what I'm going to do is I'm actually going to run a task in the DAG, and then let's hope that it will make sense. So I'm going to just take a little bit of code, and then I'm just going to pop over to here to explain what I'm doing. Essentially, this is going to run a task in my tutorial 1 DAG, and it's the sleep task. So what does the sleep task do? Let's head over to here. What the sleep task does is that it sleeps for 5 seconds and then it echoes a hello 1 step. Okay, just a really simple little hello world test. Okay, so let's just run that. And what will happen is that it will obviously not work properly. Okay, so let's try that again. And what I'm going to do is that what I'm essentially doing is that I'm trying to run this task within a DAG. And the DAG that I had it was actually tutorial 1 DAG. So let's just go back and check. The task is tutorial 1 and the task ID that I'm running is sleep. Okay, so let's try that again. No, it's not going to run for me. Okay, so what I essentially I'll go through is just a description of what this is meant to do. So essentially what you've got is you've got a number of DAGs. So let's go for this one. And you've got a graph. And these DAGs, essentially you're fitting them together. So each one is a task and they're dependent on one another. So if I now head into here and show you the dependencies, so you've got a number of tasks. What I was going to do was I was actually going to add a task here. So let's just add another task, which is a Python operator. Okay, let's just do that. Now, what this Python operator essentially does is read from an S3 bucket. So let's actually just give this a go and see if this one works. I think the odds are unlikely because I think I've broken something. But nevertheless, we'll try. Oh, it actually worked, that one. And that's good because essentially this was my data set. So essentially what I did was you can actually see I added a Python operator which read from an S3 bucket. And this S3 bucket, I don't know if anybody will recognize this, but this is the current English Premier League table. So you've got an understanding of I'm running something in Airflow and it's bringing back some data. And essentially what I've done is that I've just ran a new Python task, which is good news. So something was connected properly. Okay. Now, what I've also got to do is, so this is just one task in the DAG. Okay. Now, if we now go back to here, we've got a number of tasks in the DAG. What I did was I ran that one. Now let's talk about the dependency chain. The dependency chain is fixed by what you put in here. Now, if you think about orchestrating multiple activities, then that becomes way more complicated. And then, so let's now run the whole DAG. So now let's take the whole DAG and run that. So I'm just going to say, okay, I'm going to run the whole DAG there. And that's basically running a whole dependency chain that you can see here. So first of all, you've got to build the Python code that runs the task, test the task, and then run the whole DAG and make sure it runs. But one thing that you'll notice about this whole thread is that you've got to have each individual element and you've got to have your wits about you to make sure everything fits together as you're running it. If something fails, then where do you look for debugging? Because I think I know what I did wrong. And it was that I was referencing a T4 element, which wasn't in the code. And that's something that you've got from experience. But of course, there's no actual kind of logs that you can go to, or you've got to go through the stack trace essentially to understand what's going on. But it emphasizes my point about how everything fits together and where to go for errors. Now, another aspect of it is that when you actually run the whole DAG with a dependency chain where DAGs are connected to each other, then you've got that element of what's happened where, why is it stopped, Where do I go to? What's the dependency chain? Where in the DAG flow has it errored? Because all of a sudden you've just kicked off one DAG after another, and you don't know where to go to actually track down the errors, because it's very difficult from this view. And also, so essentially what you'd do is that you'd go down to a DAG, you'd see what's failed. So you can see what the states are in terms of the failures, and you'd have to track down your error. So all of it is very difficult to essentially put together. Okay, so now what we're going to do is build something very similar in Ascend. So remember, what we've got to do in Airflow is actually build up the infrastructure, really put together what needs to be done to actually get to the point where you're actually analyzing data. So all of this needs to be put together, needs to be orchestrated infrastructure before you even get to solving your actual problem. So what we're going to do here is that we're going to go to Ascend, and this is an Ascend dashboard. I'm going to actually now ingest some data. So let me just make sure that I'm at the right page here. That's cool. So what I'm going to do first of all is I'm going to do something very similar to what this code is doing here. I'm going to read from an S3 bucket. And the way you do that is that you do that via a read connector. So I've got a number of connections here. You can see you've got a number of pre-prepared connections. I'm going to hit this bucket. So I'm going to do use. And what this will do is a pre-built connection, exactly like I had in Airflow. I'm not building it again, but I'm going to grab the league data from here. I'm going to say that it's a CSV file, and then I'm going to generate the schema. So what Ascend is trying to do is exactly what Paul alluded to. It's trying to automate as much work for you as possible. So now it's generated the schema. It gives you a little preview of the data, and I'm going to do a create. So let me make sure I've named it properly. I'm going to name that team underscore form. Okay. And what should happen now is that Ascend has now started ingesting the data from the source into, in this case, my warehouse, which is Snowflake. Okay, so I've got team form data being ingested, and it's going through a listing phase here. The next step is another read connector. So let's take data from somewhere else. This time, I'm going to take it from Postgres. Okay, so we've got our team form data, but what I'm going to do is I'm also going to collect some other data, which is next weekend's English Premier League fixtures. So I've got my data there. I'm going to call that next week. Oops, you'll see where this is going in a second. Okay, so next weekend's fixtures. And let's generate the schema. So this is again going to pick up data from this time Postgres, and it's going to bring across that data. Cool. So now we've got two data sets. We've got essentially the Premier League table, which shows you how each team is performing over the last, I think it's 26 games or 26 games in terms of wins, draws, losses, goals for and against. And this shows you next weekend's fixtures. So what would be really cool is that if I could use some Python or some kind of algorithm to essentially predict what the results are going to be for next weekend's fixtures. So what we've got is that we've got the equivalent of this Python code, but we've built it in Ascend, and we're going to now do a transformation. So we're going to do new transform. You can transform via SQL. You can transform via different languages depending on the warehouse that you're running. But we're actually going to show you some PySpark transformation. And the key thing here is that we are now solving the problem. So if we wanted to create a model to predict what the results would be after those weekend fixtures, then we're solving the problem within seconds, not having to worry about the infrastructure. We're now just actually adding the Python to actually solve the problems. Okay, so now let's just make sure that I've done that correctly. Input 1 is team form, input 0 is team form, input 1 is next weekend's fixtures, so I think that's right. And let's call that predict. Okay, cool. So within seconds, what we've done is that we've been able to orchestrate a flow to take data in from two different places and actually create the model, which is going to theoretically, if it works, predict the results of those fixtures in the English Premier League. And this is essentially the beauty of Ascend. No longer are you having to worry about the infrastructure where it's running. Ascend is taking care of that scaling for you, depending on what model you're running, how much data you're ingesting. Because essentially, we've got customers that are ingesting millions and millions of records, and Ascend is able to scale and compute that. And you can see what we've done there. You can see we've got nice blue ticks. And if you wanted to actually see what the predictions were for this weekend's results, let's look at the results. And you can see here we've got a list of predictions about the results. I think don't blame Ascend for my dodgy algorithm here, but you can see that you've got a number of away wins, a number of home wins, and we've got the big game at this weekend is Manchester City versus Manchester United, and we've got a big win for the home team there. Okay, but the principle is that very quickly I was able to address my problem without having to worry about the infrastructure. Now, one really important thing that Paul alluded to is that this is another data flow, is that if I've got this data and I want to make a change in the middle, then with Airflow, you'd have to worry about who is affected. What if I refresh my whole flow, I'd ingest the data again. So you've got this whole concern about what's happening around you, right? So if I just want to make an innocent change, this is another pipeline. So if I want to make an innocent change to this pipeline and you were doing it in another tool, then what you'd have to do about that is that you'd have to think, okay, I'm making this change, but who does it affect downstream? And am I redundantly updating data upstream? But with Ascend, that is the real automation play because that kind of level of change management is completely taken care of for you. Because now you can see here that this change here does not make the upstream connector refresh. I'm only, and automatically it's updating my downstream connectors. So all of a sudden, what would be a big change management task and theoretically would take weeks and months because you'd have to plan about who is affected by my data change is automatically done for you in Ascend. That's the real secret sauce of that automation pipeline. You're no longer having to worry about what's affected and how my change will affect downstream consumers. Okay, essentially, just to recap, what we did was we set up a web server, we set up a scheduler, we created some code, which we changed and we ran some Python. But all of that wasn't really addressing the problem right until you were able to orchestrate the code. But with Ascend, what you can do is get into your problem way quicker. You've got infrastructure that will scale for you. And also, you can get to actually solving the problem way quicker. And also, you've got the automation pipeline, which is actually making the change management more effective for you. So yeah, that's it. I'm handing it back to Paul.
Wonderful. Thank you so much, Alesh. That was an awesome demo and great overview of how you build an Airflow, how you build an Ascend. So let's get into some of the learnings and the takeaways there. I think you summarized it perfectly, Alesh, so there's no need to go into too much more depth. But just to put it into a visual context for folks like me that like to see things written out, there is a big difference that we saw in kind of the ease of use between the two different platforms, one of them being very low code with Ascend. It is important to point out that you can interact with Ascend from the command line, and we do have a very robust SDK as well for folks that want to build additional infrastructure around Ascend and use other things and that are proprietary in tandem. But for the most part, everything is low code. So whether you're on the command line writing these SQL and Python scripts and checking them into a Git repository, which is synced into the Ascend server, or whether you are using the front end UI to create these ingesters and these transformation blocks, it's a very low code experience because you're only writing the transformation scripts. So you don't have to worry about writing logic scripts or anything else around that, where versus in Airflow, it's a very script intensive language. The a couple other things are the automation. Obviously, there's a big difference between the automated pipeline generation and the manual creation of pipelines, as Alesh was alluding to and pointing out. There's a big difference in scalability with Ascend, whereas Ascend, you can automatically scale to hundreds and hundreds of partitions, millions of records of data without a problem. And with Ascend, with Airflow, oftentimes you need to reconfigure the way your workflows are set up in order to achieve that. And so there's a lot of efficiencies of scale that come there. And then the last thing to point out is with support with Ascend, we have a dedicated team that is readily available to anybody who is working on the Ascend platform to ask questions or bounce some ideas off of or things like that. And the very responsive kind of support mechanisms. Whereas with Airflow, because it's primarily open source, it's mostly community driven support. Again, it takes a lot of time to spin up on and understand how we use that at scale. And then just to tie a bow on it, when we compare the two solutions, again, we have high code, high expertise, high maintenance, low automation versus pretty much the exact opposite when we look at the Ascend platform for low code, low expertise, and low maintenance. And that's the big one, really, is the Ascend platform was built by former data engineers, data leaders who were struggling with this challenge at scale and working at a very modern streaming media company and hiring lots and lots of data engineers to solve some of their biggest analytics challenges and realizing that they weren't really making a whole lot of progress. And the team was constantly fighting with the infrastructure, constantly being sucked into firefights that were not productive towards their end objectives, et cetera. And so that's where our founder, Sean Knapp, was inspired to, after his successful exit in that company, to go on to found this company and create the world's first platform for true automation around data pipelines at scale. And so that's what we've been working on ever since. We are coming towards the Q&A portion, so I do see a couple questions in the chat we can go ahead and get into. And if you have other questions, please feel free to whack them in. But let's just go in the order that the questions came in, Alesh, if that makes sense.
Yeah, sure. Philip asked, aside from the low code option, which is great, will there be a no code option? So what we found is that essentially in Ascend, we're offering Python as SQL as the code option. So you can transform your data using those two widely available transform sources. Essentially, what Ascend is offering you is the best of both worlds. You've got a really straightforward way to ingest the data, and you've got the ability to transform the data using SQL. I think the roadmap is probably a question for our founder and our product team. But at the moment, I don't see a no code option. It's going to be very much transforms using SQL or Python. The next question from Daniel was, is Ascend.io a SaaS offering? Okay, and how is it charged? So Ascend is actually, this is one of the main differentiators in Ascend. So the actual demo that I did is actually fully SaaS. So you can just log on, you have an environment which is stood up for you, and that can be in the EU region or the US region, and you can start building within seconds. Or you can actually have Ascend installed within your VPC. So the whole of Ascend that you saw can be installed in your VPC. And that makes it incredible for high security use cases. So you can see why a lot of customers that don't want their data on public cloud use Ascend because they can be installed within a customer's VPC. And we actually do that for you. So we have Terraform scripts which are used. You provide the servers and we'll help you install, and then we'll continue to help you upgrade and maintain that software as well. How is it charged? That might be a question for our sales team. So please do reach out and we can answer that question as well. Success stories, Lynn, definitely. We'll come back to you with some really nice case studies. We've got some new case studies which are being created as we speak as well, but that's something that you can look on our website, but we'll definitely come back to you and share that with you. And
Yeah,
Hito,
if I may,
oh,
this on that one, Alesh, that we do have a number of public case studies that are available on the website, and would totally encourage you to dive in on those. A couple of highlights, the folks that we can talk about publicly. We worked with a local consumer packaged goods company in the US that has a massive operation in terms of men's shaving products that are in a number of retail chains around the country. And their analytics engineering team was struggling because they did not have the skills to work with an Airflow, or they did not have the expertise to build out a really robust data platform. And they were struggling against some of the kind of low code slash no code tooling that was available that wasn't giving them the control they needed to be able to do complex transformations on data and be able to process it at scale, and as well as a very under-resourced data engineering team that did not have the capacity to support them. And so that's a great example where automation was able to play a massive role. And they brought in Ascend as a platform for the entire team. And within days, the team was spinning up on it. They were building out complex workflows. They were building out really complex SQL and Python transformations and prediction models and things like that. And they were happy as a clam. They really have not looked back since they moved over to the platform. And we have lots and lots of those, some that are publicly referenceable, some that are not publicly referenceable. But that is definitely the pattern that we see, is when data engineers start to get underwater with the amount of work that's required to maintain the infrastructure, that's where Ascend comes in and can really shine. Something to keep in mind.
Cool. Thank you. There was one more question from Hitomi. Again, like we talked about, could you explain the major difference between building data pipelines in Ascend and Azure Data Factory? I actually did a webinar on this last year, so we'll come back to you and share that webinar with you. But essentially, it's very similar to what you've just seen with Airflow. When I learned about Azure Data Factory, there was a high learning curve. And therefore, in order to actually get to the problem of solving your data analysis problem, there was quite a lot of steps you had to go through, first of all. And one of the main concerns I had about Azure Data Factory is that if I was a new user to Azure Data Factory, it'd be, and I built a pipeline to take data from X to Y and then transform the data and then deliver it to somewhere else. It's very difficult to know whether you've done it in the best way possible because there's so many different ways to do it. And therefore, it's not just about learning how to use the tool, it's a learning best practice. And then also about doing it in the most cost efficient way with automation. And that's what Ascend is giving you. It's basically taking away a lot of the variables associated with moving data. And that includes doing it in the most efficient way. And I'd say that was the main difference between doing it in Ascend and doing it with a tool like Azure Data Factory.
Wonderful. Thanks for running through all those, Alesh. We do have a couple more minutes if folks have any other questions that they'd like to have answered. So we'll hang on here for just a second, but just another plug for a lot of information is available on our website at www.ascend.io, and you can see more details on how the platform works. You can see more details in the form of deep dives, technical videos, and whatnot that we have. We also have a number of studies that are available on the website that reveal how we compare against some key competitors in the space, as well as the benefits of this level of automation. There's a report that's currently available on our homepage by the Enterprise Strategy Group that looks at how much this automation has impacted a number of our customers. So if you're looking for aggregate metrics, the impact across a number of different use cases, you'll find a lot of great stuff there. You'll find analysis into the total cost of ownership of the platform and the impacts that automation can have there in terms of bringing down the costs, both in terms of how much you pay for the tools and how much you pay for the data clouds that they run on. There's in the impact of the productivity on data teams that's quantified there, the reduction in maintenance that's quantified there. A lot of really good, compelling information that was compiled by a third party outside of Ascend by talking to our customers directly. And you might find that to be quite useful as well as you're poking around and quite curious. As well as our pricing is publicly available there as well. And it is a pay per use type of a pricing model. So you only pay for what you need, similar to many of these other cloud services that have all gone consumption based. Ascend is also there. And we're not in the business of charging people lots of money for things that they don't find to be valuable. I don't see additional questions coming in from the group. Alesh, I think we can go ahead and just sign off there and give folks a few minutes back in their day to go now play around with some of the things that they've just learned and think about how they can apply them in their day-to-day. But once again, this has been the Ascend Above Airflow Revolutionizing Your Data Orchestration Workflows webinar by ascend.io. Please do be in touch if you have other questions. But thank you all and have a great rest of your day.